So looking at 4-2, remember we're in our proof chapter. So we're going to start talking about the things that make triangles congruent. Those are what all of our proofs are going to be focused around. And we're just going to talk about the nuts and bolts of how do we prove that shapes are congruent. We're going to specifically focus on triangles in this chapter. And we're going to learn some shortcuts on proving that triangles are congruent. But we'll learn those in the upcoming sections. So we're going to start out by discussing the fact that when you have two shapes or polygons that are congruent to each other, all of their corresponding parts end up being congruent. So if I told you that these two triangles were the exact same shape and size, which means they're congruent, we have to figure out which of the angles and the sides would be equal to each other. So looking at the angles first, what ones would be congruent to each other? Okay, we could start with angle B and angle E. That would be one. Another pair would be A with F. And then that would leave the last ones, C with D. So along with all of the angles being congruent to each other, the corresponding sides that match up to each other would be the same length. So AC would be congruent to DF, BC congruent to DE, and then finally AB congruent to FE. So the homework is going to ask you to do problems like that, where it asks, what are all of the corresponding parts that are equal to each other? When we do have two congruent shapes, the way that we name them is crucial. It's very, very important. So for instance, on this pentagon on the left, if I name that one W, Y, A, S, T, notice that I went from here to here, 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 and then all the way to T. We have to name the other one in the exact same order so that the corresponding angles match up with each other. So if this one was Y, W, Y, A, S, T, what would the other one have to be? U, R, B, H, P. Okay, the reason that we want them in the same order is so that we don't even really need the picture in order to say which corresponding parts are congruent to one another. So looking at the next example, if we have two quadrilaterals, WSDR and quadrilateral YHJN, we want to list all of the congruent parts. So let's start with the angles. Okay, if I talk about angle W on the first one, that's going to be congruent to what other angle? Angle Y. And then we are just going to go down the line. Because it was named properly, all of these are going to match up and be in sync with one another. Okay, so all of those angles are congruent. Let's talk about the sides. So remember, when we name a shape, it's in a circular fashion, so it's going around the object. So if we have side WS, that should be congruent to side YH. Then we can just keep going. Side SD, congruent to HJ. Side DR, congruent to JN. Then let's think about what the last one would be. Remember that it's named in a circular fashion, so it's going around the polygon. RW, congruent to NY. So we're able to say what parts are congruent to each other simply based on this congruence statement right here. This is called a congruence statement. They're going to ask you to write those in the homework. Note that specifically just in this section, in order to say that two polygons are congruent to each other, all of the corresponding angles should be equal to the other angles in the other polygon, and all the sides should match up with all the sides on the other shape. Like I said earlier in the notes today, we're going to be learning some shortcuts in the upcoming sections that don't require you to say that absolutely all of them are congruent. But for today, that's the requirement in order to say that two shapes are congruent to each other. Okay, on this page, third angles theorem simply says that if you have two angles of one triangle congruent to two angles of another, that the third angles that you haven't talked about yet also would have to be congruent to each other. And we're going to use that on the next slide. And then just a refresher on proofs, since we're going to be diving into this in the next section already. These are really, really common reasons on proofs. So given, obviously stated next to anything that's in the given at the top of the proof. An example of reflexive, just to refresh your memory, would be like if you had side XB, it would be congruent to itself, or you could have an angle congruent to itself. Transitive substitution, those are very common, definition of, and vertical angles congruent. So those you're going to see quite a bit coming up. All right, so let's try some examples using this third angles theorem. I'll look at two different ways to solve these. All right, so looking at this first one, anything that's on one triangle, we can transfer over to the other as long as it's in the right spot. Notice we have this angle right here, congruent to this angle right here. So we can transfer over this 35. And the angle with just one arc on it, same thing here, we can transfer over the variable. Now on both triangles, we have all the angles filled in with something, either a number or a letter. And one of them is solvable, one of them is not. The one on the left we can solve. The three angles of a triangle add up to 180, like we learned in the last section. So we'll simplify this. Subtract 105, we get that. So now that we know that, we can use that on the other triangle. And then we can set up an equation from this one. Because again, the angles of a triangle add up to 180. So that's one way to solve these problems, using the third angles theorem, because if two angles are congruent, then the other angles would have to be congruent. We could have also looked at the third angles theorem, and the angle that we didn't talk about would also have to be congruent to each other, so we could have jumped directly to that point. Okay, or relied on the fact that the angles of a triangle add up to 180. Okay, let's look at this one. All right, so we have two congruent angles. We have the right angles here and here, and then we have these angles here and here. Let's look at just the triangle on the left. Notice that we have a 38, a 90 degrees, and then an angle where we don't know the angle measure. Well, like I just said, and we used in the last problem, three angles of a triangle add up to 180. So we could easily find that top angle. We would take 180 minus 90 minus 38 and get 52. So let's set the angles equal to each other that should be equal. So it looks like the ones with the single arc in them should be set equal to each other. And then the third angles theorem tells us that these would have to be equal to each other. Okay, then it's a simple solve on both of these. So we got 15 on that one. 19 on this one. So make sure you're just setting the correct angles equal to each other so that you're getting the right answers. A couple of things to mention about the homework on the last slide. Whenever they ask you to write a congruence statement, what they mean is to name the two objects in the correct order. So the first object you can name in any fashion you want to, as long as it's going in a circular fashion. You can name the first one any way you want. Let's say it's a triangle. Could be A, B, C, X, Y, Z, whatever letters they give you. Just make sure that when you name the second one, that you put it in the same order that you had the first one. Okay, so anytime they ask for a congruent statement, that's what they're asking for. This polygon is congruent to this polygon, making sure that you have the appropriate letters. Okay, let's go through one of the homework problems. We're going to look at number 19. So if you could get out your assignment, we will start this one together. All right, so they want us to find x and y. So let's talk about this. Let's look at the triangle on the right. How big is this angle right here? Well, we have a 90-degree angle and a 40-degree angle, and they all have to add up to 180, which would leave 50 degrees for that angle right there. Okay, the third angles theorem says that that red angle should be equal to this angle. So let's set up our two equations. We'll set the 12x plus 4y equal to 40. And then we've got the red angles, 17x minus y equals 50. Now both equations have an x and a y in them, so you're going to have to think back to last year when you were solving linear equations. There's a couple different ways to do this. I'll give you some time to think about it. How could we solve for x or for y? Well, there's three ways you could do it. One way is you could graph the two lines and see where they intersect. Another way is with elimination. And the last way is substitution. Okay, in this case, we could easily do substitution, which means that first we need to solve one of them for a single variable. The one on the right would be easiest to do because the y is nearly by itself. So let's do this. Move the 17x. And then to get y completely by itself, we have to divide everything by -1. So now we know that y is equal to 17x minus 50. Well, since I said this was the substitution method, what are you thinking we should do with this right here? This is what y is equal to right there. So if y is equal to this object, this 17x minus 50, couldn't we put it right here instead of writing y? So this equation now becomes 12x plus 4 times 17x minus 50 equals 40. Because instead of writing y, we wrote what y was equal to. We solved for it in the other equation. Now you just have one variable and you can solve for x. Once you have x, you can find y. So that's how you're going to start that one. Any questions?